Hello everyone. In this video, let's discuss how to write a program for binary tree in-order traversal. Given the root of a binary tree, return the in-order traversal of its nodes values. They have given an example. Here, 1 is root, so that is the first element. Then there is no left child, so we have given the value is null. And the right child of 1 is 2. 2 is fine. Then when I go for the next level, the left child of 2 is 3. So the input has been given here. Now we have to find the in-order traversal. The output is 1, 3, 2. And if the root is null, we have to return empty list because we don't have any element, so we have to return empty list. And if root is 1, we have to return 1 because only one element in the binary tree. Now let's see how to traverse the given binary tree with in-order traversal. Let's discuss logic in detail. Okay, so here I have taken a binary tree. Okay, 5 is the root, and the left child of 5 is 3, and the right child of 5 is 2, and the left child of 3 is 10, and the right child of 3 is 8, and the left child of 2 is 20, and the right child of 2 is 7. So here we are going to perform in-order traversal. So when we talk about traversal, we have 3 types of traversal. Actually, traversal are broadly classified into 2 types. One is breadth first traversal, another one is depth first traversal. When I go for breadth first traversal, we call that as level order traversal. Level order traversal. When I go for depth first traversal, we have 3 types. One is in order, next one is pre-order, and the last one is post order traversal. Okay, so among all these 3, we are going to see in order traversal in this particular question. So how does in-order traversal works? So in-order traversal works in the form of, first I will be visiting the left child, then I will visit the root, and then I will visit the right child. This is how I will be traversing my nodes in the binary tree. When I go for pre-order traversal, first I will visit the root, then I will go to the left child, and then I will go to the right child. When I go for post-order traversal, I will go to the left child first, right child next, and then root. This is how I will be performing post-order traversal. When I go for level order traversal, level by level I will be traversing. We will discuss that question in detail in the upcoming videos. Now let's see how does the in-order traversal works. Okay, let's take a method. So the method name is like I will give public list. We have an integer value. So I will give just integer. I have to perform in order. So here I am going to pass tree node. Okay. So here when I call the method, what I am going to do is I am going to create a list first. So how can I create a list? So list integer li equal to new list integer. Fine, I have created a list. After creating a list, I am going to call one more method to perform in-order traversal. For that, I will give the method name as in-order traversal. I am going to pass 2 arguments. One is list because I have to store all the elements in the list and then I have to return the list finally. So for that, I am passing a list and then root. Here they have given us node, right? So I will give us node. And then finally, I have to return the list from this particular function. Done. Now I have to define the method called in-order traversal. So public void in-order traversal. So here I have passed 2 arguments, which is list li, and next one is tree node root. Okay. So according to the in-order traversal, first I have to visit the left child, then I have to visit the root, and then I have to visit the right child. What if the node is empty? We have to write the base condition, right? So for that, if the root is equal to null, I have to return from the function. Here we are going to solve this with the help of recursion. So I will explain how does this work. So return, that's all. In case if the condition is not true, I will be calling the recursive call. So why am I calling the recursive call? Because you have to see left child. So in-order traversal. So root dot left because I am calling the left child. After calling the left child, I have to print the data, which is root. I will be going. So left child, root, and the right child. Now I'm printing the data. So what I'll be doing is I'll be inserting the data part. So li dot add in the list. If you want to add some elements, you can use a method called add. So li dot add root dot val, and then root over, and then I have to go for the right child. So to go to the right child, I have to call the recursive call. So root dot right. That's all. Okay. Okay. Now let's discuss the logic of Inorder traversal. So when you go for Inorder traversal, first I have to go to the root. What is the root? Root value is 1000. So I'll go to the memory location 1000. After going to the memory location 1000, here what I have to do is first I have to go to the left child. So what is the left child address? 2000. So I'll go to the memory location 2000. Okay. After coming to this node, first I have to go to the left child called 4000. So I'll go to the memory location called 4000. Now I have to go to the left child. So here the left child value is null. So we will not return anything. Okay, got over. Now I have to go for the data. So I'll take the data 10. I'll take the data 10. That will be stored in the list. Okay, stored in the list. Now I have to go to the right child of 4000. What is the right child of 4000? That is also null. So when I call null, I'll come out of this function. Once the complete function got over for this particular node, I have to go back to the place where I have called this. This is called by whom? This is called by this particular node. Okay, 4000 got over. That is left child got over for this particular function. Now I have to go for the data. So the data value is 3. The 3 has to be taken. That has to be stored in the list. Okay, done. So in this particular function, left child got over, data got over. Now I have to go to the right child. So right child is 5000. So I'll go to the memory location called 5000. In this function, first I have to go to left child. So my left child is null. Okay, got over. Next I have to go to the data part. Data part is 8. I'll add it in the list. After that, I have to go to the right child. So the right child is null. Okay, null means we cannot do anything. I'll come out of this. So in this function, left child got over, data got over, right child got over. So the complete recursion of this function got over. So I'll go back to the place where I have called 5000. This 5000 is called by this particular place. So this 5000 also over. So in this function, left child over, data over, right child over. So this complete function got over. Now I have to go back to the place where this function has been called. This function is called to be this one. So in this function, left child got over. Now I have to go to the data part. What is the data part? The data part is 5. So I'll add 5 to the list. Then I'll go to the right child. What is the right child value? 3000. So I'll go to the memory location 3000. So in the function, first I'll check whether root is equal to null. No, root is not equal to null. So I have to go to the left child. So the left child address is 6000. I'll go to the memory location 6000. So now again I'm calling the function. Check root is equal to null. No. So I have to go to the left child first. So here the left child is null. It will not return anything. Then I'll go to the data part. The data part is 20. So I'll add 20 to my list. Okay, done. Then I'll go to the right child. So my right child is null. So here this function completely got over. When I complete this function, I'll go back to the place where I called 6000. 6000 called by this one, left child. So left child got over. Now I'll go to the data part. My data part is 2. Okay, done. 2 over. Then I go to the right child. My right child address is 7000. Okay, I'll go to the memory location called 7000. Now I'll go to the left child. My left child is null. It will get returned. Then I'll go to the data part. The data part is 7. Okay, I'll print the value 7. After that, I have to go to the right child. My right child value is null, so it will not return anything. It will come out of the function. So now in this function 7000, left over, data over, right also over, I'll go back to the place where I have called this recursion. So this recursion is called by this one. So here this right child is also over. Now left over, data over, right also over. I'll go back to the place where I have called this particular function. This 3000 is called by this one. So right child also got over. So in this function, left child over, data over, right child over. So I'll go back to the place where I have called this particular function. So this is called by the main method. So I will be returning li. So this list will be written. The output is 10, 3, 8, 5, 20, 2, 7. Then we have performed Inorder traversal. This is the complete logic of the program. Now let's try to implement this as a program. So here first I have to create a list. So list, I'm going to set integer value li equal to new list of integer. Done. Now I am going to call a method to perform Inorder traversal. So Inorder, I will pass in two arguments, list and the root value. Whatever the value stored in the list, that will be returning from this function. So here I have called a method called Inorder. So I'll give public void. This method is not going to return anything. So I'll give any plus void Inorder. I have to pass two arguments. So list li. The next one is 3 node root. So first I have to check the base condition. If root equal to null, I will return. If the condition is not true, I have to call the recursive call for left child. So how can I do the recursive call? Inorder of li comma root dot left. So left child I will call, then I will be going for the data part. So the data will be added in the list. Li dot add root dot call will be added to the list. Then I have to go for the right child. Recursive call for right child. So how can I give the recursive call? Inorder li comma root dot right. That's all. This is the logic of the program. Let's try to run the code now. There is an error. List is abstract. Okay, I made a mistake here. So it should be linked list, not list. Let's run the code now. Yes, it passes the test cases. Let's submit the code. Yes, it passes all the test cases. That's all.